All right, today we're going to be taking a look at the set of real numbers and how we can tell the difference between rational and irrational numbers. Real numbers in general are just the set of numbers which contains all rational and irrational numbers. In general, everything that you've been exposed to thus far in your math education has been dealing primarily with real numbers. What we're going to start working with is the idea that there are different kinds of real numbers, and most of what you've been working with are what are called rational numbers. So rational numbers are basically all fractions or numbers that can be written as a fraction in the form a over b, where a and b are integers and b cannot equal 0 because we can't have a 0 in the denominator of a fraction. What this means is when numbers can be written as fractions, and actually we're going to refer to them more as ratios than fractions, hence the name rational number. We see that word ratio in there. These fractions will create decimals that terminate, which just means that they end, or have repetition, meaning you will see digits that repeat. Examples of this would be, for example, 5/7, 3, -1, 20 over 5, the square root of 16 because that equals 4, 0, -2/3, 1.8. All of these would be examples of rational numbers because they can be written as a ratio or a fraction of two integers. What's probably going to be new to you is the idea of irrational numbers. Basically, irrational numbers are decimals that never terminate, meaning they never end, and have no repetition. Probably the most classic example of an irrational number that we'll see is the number pi. So pi is actually a value that we see as a decimal. It's like 3.1415, and it's this decimal that goes on forever. And so it is an irrational number. The square root of 3 would also be an irrational number because it's not a perfect square. The cube root of 17 would be an irrational number because it is not a perfect cube, meaning it's not a number that can be found multiplying it by itself 3 different times. So like 2 times 2 times 2 is 8. 8 is a perfect cube. These would all be examples of irrational numbers. And you can determine a lot of these with the roots and the cube roots just by using your calculator if you don't know your squares and cubes and so on. So moving on with that, we can actually classify rational numbers even further or more specifically. So while we can always write a rational number as a fraction or a ratio of two integers, we can get more specific. So for example, we talked a little bit about integers. Remember, so integers are our set of positive and negative whole numbers. So this would include values such as everything between -3, -2, -1, 0, 1, 2, 3, on to infinity in both directions, but always that whole number. So we don't see any decimals or fractions, but it includes the negatives. Whole numbers is our set of numbers starting with 0 and then increasing. So no negatives when we talk about whole numbers, but it starts with 0. And then technically there's one more classification, and that's called natural numbers, which are like our counting numbers. It's really just our whole numbers except for 0. So the only difference between a natural number and a whole number is the fact that whole numbers include 0. We can then take this information and arrange it in kind of this different type of Venn diagram. Now, most of the time Venn diagrams, we see these overlaps between two different circles. When we're classifying numbers, what we see is these circles where there is a lot of overlap, where this group here is included in this group and also in this group and then also in this group. And then over here we have this other subset of numbers that are underneath the same umbrella, but make them distinct. So this whole area is our set of real numbers. So everything we're talking about today is classified as a real number. And then real numbers are split into our set of irrational numbers, right? So those ones that can't be written as a ratio or a fraction, or decimals that don't terminate or repeat. And then everything over here in this falls under our wide umbrella of rational numbers. So rational is the broadest term, and then we get more specific from there. So our next step is integers, because that includes positives and negatives. So every integer is a rational number. And then from there, we break down to whole, and then our smallest set is our natural numbers. What this means is every natural number is also a whole number, every whole number is also an integer, and every integer is also a rational number. Every rational number is also a real number. Irrational numbers, because they're in a separate circle, are also real numbers, but they are separate from all of these over here. Now let's just look through a few examples. We're going to try and name all the sets to which each of these numbers belong. And we're not going to go through all of them. You'll be able to use this as some extra practice, but we're going to go through a few. For example, the number negative 47. Because it's a whole number but a negative, its most specific classification would be integer. And then because it's an integer, it's also rational. And because it's rational, it is also real. So that would be all sets to which the number negative 47 belongs. Right. Now if we go to 2 3/8, since this is a fraction, it is no longer an integer. So its most specific classification would be a rational number, and then also a real number. On our next one, since we see those absolute value symbols, right, those straight lines, remember that the absolute value of -9 is actually equal to 9. So when we classify this one, we actually have to use this value of 9. Since 9 is a whole number and positive, we can call it a natural number, which means it's also a whole number, which means it's also an integer, also a rational number, and also a real number. Now we're going to look at that square root of 23. So with the square root of 23, since 23 is not a perfect square, meaning I cannot multiply a whole number by itself to get the value of 23, this produces a decimal that is non-terminating and non-repeating, making it an irrational number, but still a real number. I'm going to go ahead and jump down to the bottom. Okay, we're not going to do all these, but we're going to kind of look at what they are. All right, so for this first one, we have the negative square root of 50. Since 50 is not a perfect square, even though like 25 times 2 is 50, it would have to be like 25 times 25. But we have that negative sign in front of it. we are just looking at the fact that this would be, even with the negative sign in front of it, it would be an irrational number. So we would put it in this circle. All right, our next number is 3 and 895 thousandths. We see that decimal in there. So this is not any sort of natural whole or integer. However, it is a rational number, so we would put it under that part. We're going to do one more. So for 8, because 8 follows under all of these categories, we're going to put it in the most specific one, which would be a natural number. So letter C would go here. Try to do the rest of these on your own, and then you can check in the answer key in the classroom to see how you did.